It is 3 o'clock. So let's start the stream. Oh, let's wait 1 minute for people to arrive if they didn't come at 3 o'clock. Let me allow you to check the audio. The audio works, and we will have the notes. So today we will be LCD, debugging, LCD communication. That's what I wanted to do today and in live. So, a couple of things before we start working on electronics. Next stream will be on YouTube. I just want to try YouTube Live, if it works well or not, if it's a good alternative. I don't see any feature which Twitch offers, which YouTube doesn't offer me. I'm not considering any bits subscribers or things like that, so I don't really care. And yeah, why not? So next time I'll start YouTube, and I will still have a short announcement on Twitch, so you can switch to the YouTube channel. Oh, and the YouTube channel. Search just for QVoodoo Live. QVoodoo Live. Channels is also linked in the main channel, but I think if you look for QVoodoo Live, up, that's the channel. QVoodoo Live. You can see it there. There are also all the recordings from the previous archive, so if you want to have a look at them, it's up to date. I try to upload them fast, 1 or 2 days after I finished streaming on Twitch. So they will be on Twitch for 14 days, and for the remaining time they will be either on my archive, stream.qvoodoo.info, stream.qvoodoo.info. You can find them there. Oh, are they all here? DC motor, AC motor? No, they're not all here. There are 2 of them which are not here, part 3 and part 4. So I didn't upload them on my archive channel, but you can find them on the YouTube channel. Part 3 and part 4 are here. I think I'll continue that so I can offload my my disk space, because streaming takes a lot of space over time compared to cutting video. Now that that is done, we can try working on the project. So what LCD am I working on? Actually, I've already told you about last time when we did let me switch. Last time when we did DMX controlled AC motor, I showed you. The zoom is far too right. I showed you the oscilloscope, and one of the issues with the oscilloscope is that the leads are grounds earth reference. So you have to either isolate your target, or you have to isolate your oscilloscope if you want to measure any kind of AC voltages or mains voltages. But this also applies to other things. For example, if you want to do power measurements, you always have to do it on the low side, because this is probably because your ground is probably also connected to the earth, mains earth, so you can only measure on the low side. Sometimes you want to measure on the high side, so you either have to float your target device or you have to float your oscilloscope. So an alternative to that, and to that, is having either battery operated oscilloscope, but this is pretty rare, or have let's switch. Have a portable oscilloscope. This is what I have here, and also it's very useful because whenever I'm on site, I cannot take the huge oscilloscope with myself. It takes too much space. The portable oscilloscope is a lot more limited, but at least I can see a signal over time, because the multimeter doesn't show me the evolution over time. So for debugging communication, for debugging AC things, it's not meant there. It's just to measure voltages very slowly. And oscilloscopes can only measure voltages. Compared to multimeters, it's quite limited. But they can do it with a very, very fast and show the evolution over time. And this is why I got this portable oscilloscope for these two reasons. For in-work installation or in-work debugging, mostly for in-work debugging, and to not have the problem of having to flow to one of the two devices, because this is battery operated, it will not have an issue. But there is no mark on it, so this is a Firnsi 100 megahertz. I don't remember exactly. I thought they would have any kind of marking. You can see that it is not really meant for not really high quality, but for the price, I think it was pretty okay. Let me try to find again where I got it, so I can at least have the model number. My orders. Up. So, I found it. Is it an official store? If possible, I would like to let it on the official store. No official store. Not neither. Either way. Up. That's the device. This is, but they didn't even make the branding. It's called Firmsi. I don't remember exactly what the brand name is. I'll try to look it up. But just look for 1512H, and then you will have a small oscilloscope. I'm wondering why. Maybe if I power up, the logo will be shown. That's probably the case. Powering up. Now I know why the logo doesn't show. That is the problem. So normally, if you have this screen on there, and it should work all fine. The issue was that it is not too expensive. Okay, you cannot buy it here, but what is the price? Let's see around the price range. It's selling at something like $75, something like $60, $75. Can find a lot of things. I don't know what auto anti-burn is. I think it's wrongly translated from Chinese to English. But that's the thing, and the software on that, so the hardware is okay, but the software on that is not really good. You cannot debug. If it's a very, very periodic signal, you can debug. As soon as it is communication like UART or something like that, there's no way you can use this multimeter, this oscilloscope, to debug it. And for that, there is an alternative. This oscilloscope has also been toned down by, I think, EEV. Let me check. 5012H. Takes a bit of time. Up. So let's remove this. Up. So yeah, EV blog video 1260 has done this tear down and a small explanation of this oscilloscope. How is it called here? FNR Frinsi. I don't know how this is actually pronounced. Fnirsi. I don't know. FNAIRSI 5012H. It says 100 megahertz. It's not 100 megahertz, but I don't really care. As long as it's capable of doing something like 10 megahertz, I'm perfectly fine with it. I think at 100 megahertz you have a huge decrease in dB. Normally How it's meant is that above, if an oscilloscope is specified 100 megahertz, it means that the signal shouldn't be less than decreased or de-amplified 3 dB over its value at this range, or something like this. I don't know exactly. You will still see some kind of signal, or you can see some kind of signal, but it is not the real voltage. At least you can still see it at 100 megahertz. Here you can also still see it. But I'm not interested at 100 megahertz. I'm interested at 10 megahertz. It's perfectly fine for me. It's portable and it's usable enough. The issue with it is that the software is really crappy. And if the signal you are tracing is not very, very periodic and all the time the same, it will not be able to display it correctly. The trigger is a pain. It's really not working. So the software is not good, the hardware is okay. This is why someone also turned it apart and created a firmware for that. And I will have to find it again. I think it's this order, two of them. I think it's this one. Yes, it's this one. Up. So let's close this and let's show you this. Up. So yeah, Open 5012 from Alex Tarodov. Oh, okay, Alex Tarodov. He created an alternative firmware for this device. And his GitHub is quite good. There is a description of the hardware, so I don't have to take it apart. I will still do it because we will have to open it. The issue with that is for him it works well. For me, the firmware doesn't work well, and this is what I see when I enable it. No, okay, this is actually already changed. You see the LCD is a bit flimmering. I don't see it with the naked eye. You see it with the camera. But also it's completely white. There's nothing on it. So the firmware I know is started, has booted, but I don't have any display. And I know this is an LCD issue. So let's take it. Let's switch on the lights because now it's getting darker. So let's open the. So here, it's nice. There's kind of a rubber shield. So you can bump it all around. That's very useful whenever you are on a location with lots of other stuff to have some kind of protection. And let's open it. There are 4 screws. It's open. 1, 2, 3, 4. Let's put them in the silicon case, or thick rubber case. Let's put it on the side, and that's how it looks like on the inside. We have a battery because it is battery operated. A switch. This is just one oscilloscope probe, so you only have one channel, but for debugging, plenty enough. One channel is for me good enough. And then the inside. I think these are probably optocouplers, lots of them. Relay, mechanical relay. And somewhere here, this is the battery charger. This is branded off. This has been marked off. It probably means that this is the ADC. This is very probably the ADC. Look at the video from EVblog, or actually look at the GitHub page. He identified all the parts, and this is the ADC. This is flash. This is the clock for the microcontroller. Don't know what these things is. They're quite huge. Probably resistor dividers for the gain. I don't know exactly. The issue is that with although there's a USB port, you cannot update it over the USB. The microcontroller which is on there, which is a Giga device GD32F407, so it's kind of alternative to the STM32F407 made by Giga device, which has their own data sheet and so on. So that's good. And the issue with that is that the one which is on here, the flash has been completely locked and the debugging interface has been disabled, I think. So you can not reflash the device which is on here. Not through USB. There is no in-application flashing. So what you have to do is buy a second one from any suppliers where you can find this, and then desolder the one and resolder the new one. And with a new one, you can now program it. And how you program it is over USB. And not USB as the protocol, but the USB connector. You can see on the USB connector that there are two small signals coming from the USB connector and going through, it goes down here and then it goes to the microcontroller. These are actually the SVD connections. So whenever on most ARM devices you have either JTAG or SVD. SVD is the smaller alternative because you only use 2 pins instead of 4 pins. And with SVD you can program this device. And the SVD pins are actually available on the USB connector. So now we can really flash our device over USB. And for that I created I used this ST-Link V2 clone, which I reflashed to have a CMSIS DAP firmware. And here I have a small adapter which just takes this, as you can see, SVDIO, ground, and clock, and 3 volts. They're going, actually the 5 volt is used because you can still charge it over micro USB, so it's 5 volt input. And this goes to the micro USB connector, so I can flash the device. This is the, here's the name actually, FNR RSI 5010 SVD serial wire debugging. And here you have the pinout if you really want the pinout. That's the pinout, else the pinout is documented on the wiki. I just did whatever he did on the wiki. The issue is that his software doesn't work for me because there's some kind of LCD issue. So yeah, now you can connect it here and I can flash the device as often as I want with the new chip. The old chip is completely locked, so you can just either you keep it because you want to replace with the old software, or you just get rid of this chip completely because I think it's not, I think the debug interface is completely disabled, but I didn't test it really, or I don't remember. It's been a long time, and you cannot reuse it. So, he also documented LCD interface. I don't know what LCD interface, what is this? Is this a full bridge rectifier? I don't know. It's a weird package. Is it written? So let's unscrew to see if the LCD interface is documented, and we will still need to debug the LCD to see if the communication, what is wrong on the communication. I tried changing a bit the code on the LCD. I could get some kind of display, and we will try it out, but nothing really stable. Up the screws somewhere safe. Up, that's the device. The LCD is on the side. Can get rid of, although we can leave it on. It's not in the way for now. I don't know on which pin the LCD is. It's probably documented also either in the source code or in the documentation in the wiki. And we'll probably tap the pin signals on there. But first I want to see if I can have a look at the connection. So it's a flat ribbon connection. Probably it's directly going to the pins. There's nothing in between. And I don't find any marking for the screen, what kind of screen it is or what the chip inside is to drive the LCD. now we're removing the backing, which is so this is to reflect the light from the LED back to the LCD, so we need to put this back in. Here's the marking. It's me. Let's get this tape. It's probably not good to have it completely bent. Let's try to put some alcohol up on. Ooh. Let's put some alcohol on the back to try to see if we can remove or loosen the glue on the thing. Though I don't really require it, but I still want to do it because I'm curious. Yes, it loosens the glue. One side, so the same for the other side. I hope I'm not ruining too much the device. Yes, that helped a lot. I don't know what this kind of thing is. Oh, you see it retracted itself, probably with heat. I don't know exactly why. And not all pins are soldered. You see the 4 pins syrup. The 4 pins here are not soldered, but they don't seem to connect anywhere. You don't have any trace, so I don't know why they put to the connector. Maybe to be more universal. I don't know. Can remove this tape. We will put new one on it once we're finished. Double-sided tape. Yeah, I've bent a bit the thing, but it should be reflective enough. Actually, they put it on the wrong side, didn't they? Here it seems there are strips to... Yeah, that's weird. I think these are double-sided strips, so you can glue it on the screen. Is it this way? Double-sided tape. Yes, it is. This is double-sided tape, which normally you remove, and then you can glue the double-sided tape on the LCD screen, or the shield on the LCD screen on the side, and it didn't do it, so yeah. Yeah. But I mean, for this price, what do you expect? And they're not... Problem is that handheld oscilloscope are very expensive normally, so either very shitty in the very low market, low range, under $50, or very, very expensive. And I wanted to give a try with this one. Thought the idea was good, and if the firmware, the alternative firmware works well, then we have a win. So let's fix the screen actually. Put it on the right side. And yeah, just get rid of this. I don't know what this kind of foam is. It doesn't glue. I think it's just to back it up a bit so it springs correctly, because the LCD, the board wasn't high enough. This is just, don't see it, IPA is just 99% isopropanol. Nothing special. And it works generally well against glue. I have something a bit better against stickers, but for general operation this is good enough. Glue remover, this one. Sticker remover. I think the sticker remover will have to use it on the other device. Let's use some other pliers that probably have enough more force. Okay, too much glue. Up. Actually, I have something else which could be useful. Up something like, nope, not this one, this. Up, scraper. Some plastic scraper, very useful for removing stickers. Still think I don't have the right glue remover. Oh, it doesn't work that well. Works okay. Up. Still some glue there. Can feel it with the finger. It's probably not visible with the camera, but I can feel it with the finger. Up. Then in the bin. This goes here. This is for later. This goes on the side. I have more space. I have to run the fingers now. Up. Let's try. This is just something specially for stickers, and I find it very good. So isopropyl alcohol, if you have nothing else, is good enough. But there are some dedicated chemicals which work a lot better, like this one, which is especially meant for removing the glue out of stickers. I don't know the formulation to have, but it has a strong smell, and it works really well. So that's one side. So we can now put it correctly. Oh, I don't know. There were also bands of glues on this side. It's probably not very visible. So they probably did it the right way also. It was not holding too well though. So let's use the other side. Let's have it as clean as possible, because we want it to reflect the light back to the screen, like inside the screen. Up. Let's remove the tape. One side. Up the other side. Let's put the backing. Oh, now it holds well. And the table. glue is removed. That's trash. We will put some other kind of foam. And we also have to remove this tape, although it is still a bit sticky, but I want to remove it. Up. We can actually figure out the pinout ourselves now. Once we identified the sticker, I've never played a lot with LCD screen. The only LCD screen I've played are the big ones, 2-line, kind of dot, I think 8 by 5. So disconnect the battery. 8 by 5 dots. This we can also remove. I think it's Hitachi HG 44780, something like that. Up. Come on, loosen up. I have some other thing which I wanted to try. Be careful when you are on the solder points. I don't want to break the flex cable because flat flex cable are really hard to repair without burning. They're just so fragile. And even if this is polyamide tape, you burn through it really fast. So let me try another thing which is there to remove the stickers, but works a bit differently. Here. I like to buy sticker removers to see how it works. This one works a bit differently. It is not a spray or very liquidy. Well, it is liquidy, but as soon as you place it, there's kind of a bubble which forms on it or something, some kind of gel. I think on contact with air it forms gel. And the idea is that you rub it against the sticker you want to remove, and apparently removes it. It works well with stickers. It doesn't work well with this double-sided tape. I think I'll stick to the, although it works, but probably to remove the remainings it seems to work. Let's try it. Up. See, some kinds of gooey thing. I don't know what this is. It's weird. No, doesn't work that well. Let's close it. It seems to be very reactive to the thing, and let's try with the other spray. Yes, it works better. So now we're not really debugging it, we're cleaning it, but hey. That's also part of the job. It would be nice if this portable oscilloscope works, because currently I have no oscilloscope, portable oscilloscope. I just have this bench oscilloscope Oh, almost done. And it looks almost shiny. Not perfect, but good enough. If you also be aware, if you try new solvents, try them on one of the plastics to see if it dissolves anything or not. I had an issue with, for example, silicone lubricant and with silicone domes, something like these tactile domes. I'm not sure if this one is, but the one I tested was made out of silicone, and it was just making it very soft because, well, silicone lubricant has silicone solvent, so the silicone stays liquid. Okay, now let's test if this still works. Should be at least white, meaning it does something to the screen. Oh, now it works a bit better. I don't know why. Timer overflow. This is, so when you start it, I see that is, the timer overflow is because I already started debugging it quite some while ago. And I thought it was because of the LCD, because everything else was working, and the LCD was very I'll show you actually how it looks like originally and what I did so it looks like this way. But the LCD is still working. That's something which is good. Then it shows time overflow. I don't know why it shows it now and it didn't show it at the beginning. I'm not sure that cleaning anything here did result in any change. I'm not aware of that. Who knows what's happening? So, how is it called? TF24328. Let's see if we find a data sheet for that. TF24328 LCD. I just want to see if the marking, we can find something based on the marking. Not really. Else we'll just use the wiki. So let's have a summary. Device is handheld oscilloscope. Handheld oscilloscope. The trigger doesn't work. It's not consistent. I cannot show you to you anymore. Consistent. Okay. I cannot show you anymore because I desoldered the chip. I don't want to resolder the original chip back. But I know I have it somewhere. Boom, boom, boom. MCUICs. I don't want to look for it. It's just the same chip, just with the original firmware, and don't really require it anymore. So the trigger is not consistent, and signal needs to be perfectly periodic. Okay. So we're using an alternative firmware. Firmware is Open 5012H. 5012H. Let's put the GitHub link. Up. Issue. Display has issue. displays garbage data on my device. Let me try to show you what it does. I'll reflash it. I'm sure I have the firmware somewhere. Hep. Get status. Yes. Oh, I even have the flashing command. So let's see what the LCD is. PNP transistor display based on this device, TFT display. Okay, ST7789S. I need the datasheet because I'm sure there's something wrong with the timing in the firmware. The firmware doesn't use any real hardware timers to have correct timing. It only does bit banging. Specs. I'm sure this is a very common interface. I don't really know. But if it's written there, and it does display something. So yes, I have the data sheet. I'm not aware of the data sheet yet. So let's remove this. I'll keep it for me somewhere here. And these are the changes I made. You see, I've added knobs for it to work correctly. To have git log. No, I didn't do any change. So git status lcd.c. lcd.c. It's probably very small for you. Let's switch to the screen, and I hope that is big enough. So the data has been output somewhere. I'll find my code again. No, I don't find it. Volatile. Here. LCD write data. This is to write the data out to the LCD. Previously there were knobs. Let me just copy this. And originally there were knobs. Let me show you how it does then. I'll just back up this. Yeah, I can use git for that, git stash and so on. I don't want to. Git checkout. Let's check the original LCD out. The make file is just a change, so I can flash just with make flash. The setup is already here. So here the screen. I will connect the USB. Well, the USB connector, but the SVD signal. Tac, it's connected. Let's get USB cable extension. Up, because it's not far away enough. Okay, USB here. So here's my USB cable extension. Connecting to the device. Up. Okay, cable extension is here. put it this way. Oh, let's have it the correct way around. You can see my reflection this way. Something like this. And something is wrong with the capture card. Did something happen? Yes, the capture card died again. Unplug and replug it. Capture bar is back up, but as always, OBS doesn't work anymore. Does it? Let's try. Armcam, tac. No, it doesn't work. I'll be back in 2 seconds, so I'll see you again on the stream. I don't know how to restart the OBS without restarting the stream, so I'll be back soon on the stream. Stop streaming.